Hey there, I'm Dan Bader, and today I want to talk about a question that I got from a reader a while ago. So the question was about what is the minimum data structures and algorithms knowledge I can get away with? And they say, in my work as a QA person, I rarely use any linked lists or graphs or algorithmic approaches. Though I love writing Python code and learning the language, but I am very bad at math, data structures, algorithms, and competitive programming. So I would like to learn just enough data structures and algorithms in Python. So I guess the question is about how much data structures knowledge do you need to get a developer job, or I guess to be successful in your career. I feel like that's sort of the spirit of this question, and I think it's a really, really great question because there's a lot of I feel like on the one hand there's a lot of scaremongering about, oh, you gotta have, you gotta be able to, balance a binary tree and write a red-black tree from scratch on the whiteboard. Otherwise, you're never gonna get a job and you're gonna die poor and, people are gonna hate you. And on the other hand, there's kind of a lot of backlash from the other side where people are saying oh, you know what, any data structures knowledge is completely useless. People only use that for interviews. Why would you even, have to learn that? It has no practical use in the day-to-day work of a developer. So we kind of have these two extremes, right? Where I guess people are saying, okay, if I need to demonstrate this knowledge to get a job, I'm totally expecting that this would help me on the job. And this is probably why people are asking and testing for it. And the other side is saying oh, that's totally not true. This is just all people interviewing developers in the wrong way. And actually knowing about data structures and algorithms is not that useful in practice. And for me, I am not on either end of that spectrum. So I want to give you my personal perspective on this stuff. And I have experience, I've gone through several of these interviews and the classic whiteboard interview and screening. And I've also put other people through them and interviewed other people and stuff. So I feel like I've got a kind of balanced perspective on this. So in terms of the data structures knowledge you need, to get away with, first of all, I think it's dangerous to say that data structures and algorithms and all of the fundamental computer science stuff is useless and you can be a great coder without that. That's like saying, I'm going to be the world's most amazing pilot without knowing anything about aerodynamics. And it's just not going to work. Sure, maybe you can get your plane off the ground, but you better be careful so that you don't kill a bunch of people, right? So if you do that in a professional capacity. And so I fundamentally believe that having decent, solid data structures and basic algorithms knowledge is a skill that's worth having. And it's important for any software developer that wants to grow their career and that is really serious about software development. And it can also be very rewarding. This is something that I still practice every once in a while because it's easy to forget this stuff, and it's hard, right? But it's also fun once you make some progress. So, for example, I just I'm working on this book called Python Tricks, the book, and I created a series of data structure chapters there that cover some of that cover the classic computer sciencey data structures and how you can use them in Python, where you can find them in Python. What is a queue? What is a stack? What's the best way to implement a queue or a stack in Python? What's a dynamic array versus a linked list and stuff like that? Very sort of basic data structures knowledge. And I feel like that this stuff is immensely valuable for any developer to know. So, when I was writing these chapters and I did a bunch of research and I had to, come up with some examples and then, make up my mind what I was going to say there, I actually benefited from that. Even though I knew most of the stuff beforehand and had been working as a software developer, for several years, I benefited a lot from freshening up that knowledge and refreshing my memory on that stuff. And so, I think having this knowledge is very, very beneficial to your day-to-day work. It's just going to make you a more effective coder. You're going to be able to avoid certain classes of problems that someone else might just run into head first. And then they're going to have to backtrack and figure out where they went wrong. If you know some basic complexity analysis, you're just going to know, like, if I write like 3 nested loops, and in the inner loop, I'm going to hit the database a bunch and run some queries, that's going to have horrible performance if I do that, at any capacity. Like if I do that 100 times a second, it's just not going to be that great. And if I do that 1,000 times per second, it's going to get worse and worse and worse. So having a basic amount of data structures and algorithms knowledge is immensely helpful. Now, of course, you can take that to the other extreme, and you can have the person who can like write a red-black tree implementation for you on the whiteboard, and they're good at these sort of competitive programming questions and competitive algorithms questions. Like, to be honest, like I am not one of them. Like, I tend to freeze up a lot when I get these questions. I've gotten a lot better at it, and some of it was just out of necessity, right? A necessary evil for me to be able to get the job and to get the jobs that I wanted. I just had to become more comfortable with this type of interview. But do I think that the person who you can do all of this stuff on the whiteboard, are they fundamentally like a more effective and a better programmer? Well, I don't know. Like maybe part of it is my own bias, where I'm thinking, well, guess what? I can't do that. So the people who can do it, they don't have an advantage. And, it's no point in learning that skill. On the other hand, there's probably some advantage, but I also think it's all diminishing returns, right? Like there comes some point where, if you have a little bit of data structures knowledge, that's going to be super valuable for you. And then if you have a little bit more, that's going to be also still valuable, but a little bit less so. And like the more knowledge you have, you kind of reach these diminishing returns, like the curve peters out, right? And I feel like it is like that with data structures knowledge as well. So like the person, who knows what a binary search is and has like some solid like complexity analysis skills, right? They know how big O notation works, and they actually understand it when you look at code, and they can kind of make these come up with these like subconscious feelings about like, oh, is this code going to be fast or not? And they kind of have a sense for what makes a slow algorithm, what makes a fast algorithm. If you take that person and you compare them to the person who can write a red-black tree from scratch in 10 minutes on a whiteboard, I'm not sure if that is so much of an added benefit in real life, right? Because at some point, like once you've gotten the job, like a lot of it comes down to like, hey, are you actually a nice person to work with? Can you help the people around you to work better and faster and maybe be a little bit more happier? And there's just so much more leverage in that, in my opinion, versus actually going like, being like Rambo, like the lone hero, and you're just coming in like, yeah, guys, I got it. Like I'll just drink more coffee and bang out a bunch of extra code, and I write this like red-black tree from scratch. Like, in fact, most people would probably not write a very complex data structure like that from scratch, because even for someone highly skilled, that is more of a long-term effort, right? It's not like a lot of times it's very easy to come up with these algorithms on a whiteboard that work for those specific cases, and they're good enough for an interview. But then when you actually use them in practice, you have to worry about all kinds of other things, right? You have to worry about maintainability. Is this code readable? Do other people understand it? Is it well tested? Does it validate its inputs? And there's a lot of this just the practical knowledge there, how you would be a practical software engineer. You would probably not write your own red-black tree, but you would, based on your knowledge, you'd be able to find a really good off-the-shelf implementation and then use that in your own programs. And that's what makes you more effective, right? So I think I like to think there's a difference between, someone being able to do that on a whiteboard and then them actually being a very, very effective, productive developer that actually delivers great work, right? Those are not necessarily the same thing. And so to reel all of that back in, sorry for the rambly answer there, but to reel all of that back in, how much algorithms and data structures knowledge do you need to, what's the minimum you can get away with? And I hope what I just said, it gives you a better view of that whole spectrum. So the minimum is probably not at a like Google interview level, whiteboard coding kind of knowledge, right? Like it's the minimum you can get away with is like, in my opinion, it would be like, knowing about basic data structures, like what is a queue, what is a dynamic array, what's a linked list, how does a dictionary or a hash map work, and how do these basic data structures work, and what are their relative performance characteristics? Right? When would you use them? I feel like that knowledge is already going to take you very far, and that's probably what I would have as the minimum. Of course, the question is like, for the minimum for what, right? Like if you just want to get a job as a programmer, maybe you can reduce that minimum further, and you could just say, okay, I know the basic data types in the language that I'm working with. I know what a list is in Python. I know what a dictionary is. I know what a set is. And I know how to work with them. I sort of know under which circumstances one is better than the other, or faster or slower than the other, how much memory they take up. And then maybe you don't need much more. Maybe like you need even less. But I feel like, somewhere in that range, this is where I would put the minimum for someone to be a highly effective and highly employable software developer. But it's, in my opinion, probably not over there where it's like you're the person that writes a red black tree from scratch in a interview situation, right? So it's more on the other end of the spectrum, to be honest. And okay, so let's go over that question again. So there was one other bit here about being bad at maths and being bad at data structures and algorithms in competitive programming. So I wasn't actually great at math when I started my computer science education in Germany. So it was a bit of a hard landing for me. And actually, I got myself like so psyched out and worried before I even applied for university that I almost didn't do it. And by that time, I had actually been paid to do programming work, right? But I felt so incompetent, and I felt like I wasn't ready for it because of my not that great math skills, that I almost didn't do it. So now thinking back, that would have been a horrible decision, if I hadn't gone. Because for me, it's a complete passion. I love programming, and I got so much joy out of my education there. And I'm glad I went, and I'm glad I applied. And it was hard work sometimes, but it was absolutely worth it because I got to work on stuff and learn stuff that I absolutely loved, and I got to hang out with people who were in the same situation. So that was a great value to me, right? But what I want to say is that don't feel like you can't do this because you're not a math wizard. Like I said, a lot of things in programming, they actually come down to more like thinking like an engineer. I totally, to explain that, what I mean by that is like, of course, you want to have like, you want to be thinking analytically and like rationally and logically, but it's math again is a wide field, right? Like I found that there were some parts in mathematics that I felt like really comfortable, like Boolean logic and stuff like that. I felt really comfortable, and then other things, not so much. So it's a wide field, and for you to be a successful programmer, you're not gonna have to be an absolute master at every single, like on all of it. Right? Like if you don't know, like I was really struggling with differential equations. So if you don't know how to solve them and you hate them, it doesn't really matter. You just find a job where you never have to deal with any one of those ever again. Or maybe, you can just tap your coworker on the shoulder, or maybe you can just hire a consultant to figure that out for you, that particular thing. And then you're golden and you can move on. Like what I really enjoy is about designing systems and building systems, and also building them in a way where they're maintainable and like nicely structured. And I get a lot of joy out of that. And to a certain degree, you could say, that is also like a more like well, maybe some sort of mathematical ability. I think it's related to that. How do you think logically about like how can you build a system? Where do you start? In what order do you build things? Where do you add things? And these are all, I feel like they're all skill sets in the same, they're all part of the same spectrum. And you don't have to be a master of all of them to have a great time as a programmer, and also to have a successful career as a programmer. All right, so I hope this helped you out. Don't go too crazy, and don't psych yourself out too much about these algorithms and math questions. This is a skill you can learn if you already have some programming knowledge. Sounds like you're working in QA and you're doing programming work there. That's awesome, and that's a fantastic foundation you can build on, and then add these other skills that you need maybe to make it through a classical developer interview whiteboard kind of situation. All right, best of luck with that, and thanks for the question.